This video is part 1 of an introduction of functions. We'll start with some definitions. First, a relation. A relation is a correspondence between two sets. So for example, if X is an element of set A and Y is an element of set B, and there's a relation formed between these two sets, we say that X corresponds to, or goes to, or maps to Y, and symbolically we can write that as X with the arrow to Y. This is just a way of matching up elements from the first set A with elements of set B. We have a name for the set of all X values, and these are called the inputs of a function or of a relation. The set of Y values are called the outputs. So basically you take an X value, you start with that, and then that goes to some Y value, which is your output of your relation. Now there are different ways that we can represent relations. The first way is called a mapping, or sometimes an arrow diagram. This is a diagram that uses arrows to show the correspondence. So in the example here we have a relation between months of the year and the number of letters in the name for each month. So here we see that January maps to 7, February maps to 8, March to 5, April also to 5, and May goes to 3. Another way that we can represent a relation is with a set of ordered pairs. And this is just taking the elements, the inputs and the outputs, and forming ordered pairs with the input going first and the output going second. So here's a list of ordered pairs from the previous example. And so notice here we have January as the input and 7 as the output, and so forth. Now, the order in which the input and the output are listed in the ordered pair is important, but the way that the ordered pairs are listed is not important. So I could put May, 3 as the first ordered pair, and so forth. This is just a set, and remember, a set does not have any order. Now, most importantly, we like to look at relations that have these special properties, and these are called functions. So here's our definition. Given two non-empty sets A and B, a function from A to B is a relation that maps each element from A to exactly one element of B. So very often functions are written in terms of the variables x and y, where x is called the independent variable or argument, and y is the dependent variable. We can also still think about x as the input and y as the output. If a function is written as a list of ordered pairs, no two ordered pairs will have the same x value with different y values. And we have special names for the group of the inputs and outputs. So here we have the domain, which is the set of all x values. In our definition above, this would be our set A. Now the image is the y value of a function at a particular x value. So the image is one y value that matches up with one particular x. Now the range is considered the set of all images, so all of the y values that are used. In the above definition, this may be all of set B or only part of it. So if you take a look at the mapping that you see here, we have set A as this entire group, set B is this darker purple color, and we have x values that are in the domain. So everywhere an arrow is pointing or coming from is another x value in the domain. And they are mapping to a particular y value, which is in set B. Now, if we take all of the y values that are used from set B, we get the range. So notice that we don't have to use all of the elements in the set that we're mapping to. Sometimes we do, sometimes we don't. Alright, so we're going to do some practice determining whether relations are functions. And we'll start with some lists of ordered pairs. So with number 1, you have a list of 4 ordered pairs, and take a moment to decide if you think that is a function. Remember, using the definition that each x value, if it appears more than once, it has to have the same y value with it. So if you take a look at 1, we have all different x values, 2, -2, 3, and 1. So there's no way we can violate our definition. So this would be considered a function. Example number 2, if you look at the x values, we have -3, -2, 1, -3, and 4. Now we have 2 ordered pairs that have the same x value of -3. These ordered pairs have different y values. So this violates the definition of a function, which means it is a relation, but it is not a function. In example 3, we have a mapping, the same example that we looked at earlier. And this is our example of months to the number of letters in the name for that month. And since there's only one arrow coming out of each input, this would be considered a function. January only has 7 letters. It doesn't have any other number of letters. Same with April and so forth. Now if we take a look at example 4, which matches months with some names, so maybe this example would be about who has a birthday in which month. So June contains the birthday of Angelo, August contains the birthdays of David and Molly, and March contains the birthday of Susie. So here, if you take a look at August, August is our input, because that's where our arrow is beginning, and that is mapping to 2 outputs, David and Molly. So because of that, this is not considered a function. So once again, number 1 and number 3 are functions. Numbers 2 and 4 are not functions. Now, quite often we, again, represent functions as equations using the variables x and y. Sometimes there are other variables that are used, but equations are often the way that we represent functions. So there are 2 ways that we can represent an equation. The first way is called implicit form. This is just any equation of a function using variables x and y, or whatever variables you're using to represent your independent and dependent variable. Notice here we have a linear equation in standard form, so it is not solved for the dependent variable y. This is implicit form. So it's implied that this x is this y is a function of x, but it's not written in that way. To compare that, we have explicit form, which is an equation of a function that is solved for y, or the dependent variable, whichever that is. So in this example, we have y equals, and then some expression containing the independent variable x. That would be explicit form. This is useful because it helps us to determine if equations are functions. We'll see that if we can solve the equation for y and get one particular y value for each x, we will be able to determine that equation is a function. And that's what we're going to do in the next example. So again, the question is it a function? So in order to determine this, we're going to write the equation explicitly. So we're going to solve it for y. If an x corresponds to more than one y value, then it's not a function. And there are some shortcuts here, but I want you to try these first. So take a moment and solve each of these equations for y and decide whether or not you think they are functions. So take a moment and pause this, and then when you come back, we'll look at the solution. Okay, let's take a look at number 1. So once again here we had an equation that was linear looking. We have 3x minus 2y is equal to 8. So we're going to solve this for y, just subtract 3x on both sides. So you get -2y equals 8. Or excuse me, -3x plus 8. So divide by -2 to get y is equal to 3 over 2x minus 4. So here, this is just a linear equation. we know that no matter what x we plug in, we're going to get exactly one y out. We'll never be able to plug in one x and get two different y values. So this would be considered a function. Alright, so now in example 2, we did not have a linear equation because we see x squared and y squared. So here we'll solve for y once again. We'll subtract x squared from both sides to get y squared equals 1 minus x squared. And then to solve for y, we have to take the square root. Don't forget to take the positive and negative square root of the side with the x. So you get y equals plus or minus square root of 1 minus x squared. Now this plus or minus is really going to tell us that we have two different values for y. So let's let x equal 0. We plug in 0 for x, we get y equals plus or minus 1 minus 0, which is 1. And when we take the square root, we get y is plus or minus 1, which means we have two ordered pairs, 0, 1, and 0, negative 1. So we have the same x with two different y's, so this is not a function. Alright, so I hope you enjoyed the video today about is it a function. Make sure to look for the second part where we will determine domain and talk about the arithmetic of functions.